My name is Diaz, and my topic is inverted F. Inverted F is a type of antenna used in wireless communication. It consists of a monopole antenna running parallel to a ground plane and grounded at one end. The antenna is fed from an intermediate point 18 amps from the grounded end. The design has two advantages over a simple monopole. The antenna is shorter and more compact, and the impedance matching can be controlled by the designer without the need for extraneous matching components. Inverted F antennae are widely used in compact handheld wireless devices, where space is at a premium. This includes mobile phones and tablet computers that is using wireless transmission such as GSM, Bluetooth, and Wi-Fi. IFA basics. The feed is placed from the ground plane to the upper arm of the IFA. The upper arm of the IFA has a length that is roughly a quarter of a wavelength to the left of the feed. The upper arm is shortened to the ground plane. The feed is closer to the shortened end than to the open end of the upper arm. The polarization of the antenna is vertical, and the radiation pattern is roughly donut-shaped, with the axis of the donut in vertical direction. The ground plane should be at least as wide as the IFA length, and the ground plane should be at least lambda over 4 in height. If the height of the ground plane is smaller, the bandwidth and efficiency will decrease. The height of IFA should be a small fraction of a wavelength. The radiation properties and impedance are not a strong function of this parameter. The slot antenna. The slot antenna should be a half wavelength long or proper radiation. The way this antenna is fed, the voltage at the ends of the slot across the aperture must be zero because of the shorting post on the ether side. If the voltage is zero at the edges of the slot, then the voltage will be at a maximum quarter wavelength away at the center of the slot. Voltage and current distributing by slot antenna. Now, where is the current at a maximum? Since this antenna can also be viewed as a transmission line, the source basically sees a shorted circuit in transmission line in either direction. We know from the transmission line theory that when a transmission line is short-circuited, the voltage and current are 90 degrees out of phase. As a result, the current will be zero at the center of the slot antenna and will be maximum on the edges. The voltage and current distribution are shown in figure. Note that the peak voltage is assumed to be A volts and the peak current is A amps. The slot antenna radiates because voltage is in phase across the entire aperture, so that E field is vertical and lines up everywhere along the slot. This also gives rise to the vertical polarization. circuit model or inverted F. For interpretation, we need the antenna to be a good radiating structure, and we need to be able to target the energy down the transmission line and onto the antenna. This means we need the impedance of the antenna to be 50 ohms, which is typically impedance. To accomplish this, it is desirable to have a reactive component of the impedance, imaginary part to be zero. For the IFA or slot antenna, note that the feed sees a shorted transmission line, a small fraction of a wavelength from the antenna. A shorted AX line is a small fraction of a wavelength, creates an inductive reactive component. Similarly, the open circuits on the IFA creates a capacitance to the right of the feed. The feed location is chosen to balance out the capacitance and the inductance. The inductance and capacitance cancel out, leaving just the radiation resistance. An equivalent circuit model of the IFA is shown. Note that the slot antenna, the short circuit to the right of the feed still creates a capacitance because the length of the slot to the right of the feed is larger than a quarter wavelength. In regards to the real part of the impedance for an IFA or slot antenna, note that if the slot antenna was fed at the center of the slot, where the voltage is maximum and the current is zero, C equals to voltage over capacitance or current. The impedance will be practically infinite, so that the antenna will not radiate. By moving the feed away from the center for a slot, this also shows the current to decrease from zero, which allows the impedance to drop to a more desirable value. The same is true on the IFA antenna, hence the feed location is a critical factor designing an IFA or slot. A good location for the feed can easily be obtained experimentally during an antenna design. Inverted F in real world. IFAs are commonly used in mobile phones due to their small size. An example of several IFAs in mobile phones can be seen clearly on the palm tree. These antennas are visible once the back cover is removed. It is shown in the figure. The yellow strip on the left side of the palm antenna is the GPS antenna, which is an IFA. Since the GPS frequency is 1.575 GHz, a quarter wavelength is about 1.87 inches or 4.75 centimeters. This is roughly the length of the IFA in the actual product. It is shortened for the proper tuning. Two other antennas are visible in the figure. In the upper right side, there is the diversity antenna, which is receive-only antenna, does not transmit. The bottom of the device is a dual-band IFA. This antenna is the transmit or receive cell antenna, which should be operate at 900 MHz and 1800 MHz bands. To do this, the antenna engineers made an IFA for the high band, which is shorter arm shown in figure. Using the same feed and the shorting end, they branch off another arm for the lower band. Because the designers had limited space, they wrapped the IFA around itself on the edges. By doing this, they were able to obtain the required length for a 900 MHz IFA. However, by wrapping the antenna around itself, the antenna and radiation efficiency decreased. This is the multiple choice 1, 2, 3, 4, 5. And the summary is inverted F antenna is a type of antenna used in wireless communication that consists a monopole antenna running parallel to a ground plane and grounded at one end. Inverted F antenna are widely used compact handheld wireless devices where space is at a premium. That includes mobile phones and tablet computers using wireless transmission such as GSM, Bluetooth, and Wi-Fi. The slot antenna should be a half wavelength long for proper radiation. And that's the end of my presentation. Thank you.